space of time is a landscape and we move through it. But do we really understand time very well? Is time the same for everyone? Well, in order for us to understand time, today we will discuss the special theory of relativity, which was developed in 1905 by Albert Einstein, a famous scientist. This theory existed as a response to the long-debated conflict between James Clerk Maxwell's theory of electromagnetism and Isaac Newton's three laws of motion. This theory broke the traditional understanding of time as a constant entity and was proven that time in fact is different for different observers. Albert Einstein's theory called special relativity because it only applies for specific situations where different frames of references aren't accelerating. So now, let us now dive into our topic and be ready to learn together with us.
Imagine you are traveling with Einstein in a train moving at a certain uniform speed. The train relative to the outside environment is in motion. The two of you, sitting inside, on the other hand, observe each other as stationary objects as both you and the train are moving at the same speed. Hence, relative to the train as stationary and the laws of physics stay the same even though as they would on the ground when you are standing still.
Now, let's consider you get off the train and observe it moving across in front of you. Now you are stationary and relative to you, Einstein is moving with the same speed as the train. This is the phenomenon of relative motion and we observe it every day. Does everybody in the universe observe this relative motion the same way? Yes.
According to Maxwell, the light in a vacuum moves at a constant speed of 186 miles per second to any situation and to any observers. On the other hand, according to Newtonian physics, all speeds are relative, which means that the speed depends on the observers, its viewpoint, and the situation.
And because of these two opposite ideas about time, speed, and everything, Albert Einstein proposes the special theory of relativity. In his theory, he's pointing out that both of these theories are true. He solved these conflicts as he proposed the two foundations of special theory of relativity in the year 1905.
The first principle of Albert Einstein's theory is the consistent law principle. It states that all motions are relative to the selected reference or viewpoint, which means that every motion of a thing depends on the observer's viewpoint.
For example, an astronaut in a spaceship who is moving towards the source of the light thinks that the light is moving at the speed of 186,000 miles per second. Therefore, if there's another astronaut who's not moving towards the source of the light, must also think that the light is also moving at the speed of 186,000 miles per second. In short, regardless of the rate of movement of the source of light and the rate of movement of the astronauts, the speed of light will remain the same. No matter how fast the observer is moving or a light emitting object is moving, the measurement of light or the speed of light always yields the same result.
For example, if a person is inside the train and in a position where he or she can see two trees that the train passes through, and then after a short time, while the train is moving, a lightning hit the two trees, but according to that person, he or she first saw the tree on his or her right side before he or she saw the tree being by hit the lightning on his or her left side. But on the other hand, some other person inside the train also saw that happened, but what differentiates the two is that the second person both saw the two trees being hit by the lightning at the same time.
To conclude everything, this all means that what they saw and what will they see depends on their position. On the train, they are standing or they're standing on the chair of the train. Because what you can see depends what is only visible to you. You cannot see what is happening behind your back if you are looking whatever happening in front of you.
But we also need to understand that while the object is moving in a straight line at a constant speed, the laws of physics is the same for everyone. Therefore, we need to remember that the laws of physics are the same in all frames of reference that are moving at a constant velocity with respect to one another. For example, if you are in a train and you look at the window and then you saw another train that is moving too, the question is, what is moving? The train or you? It is hard to answer which is which. That is why Albert Einstein recognized that if the motion is perfectly uniform, it is literally impossible to tell which is moving.
Next principle of Albert Einstein theory is the principle of speed of light, which is the constancy of speed. According to this, the light is moving at a speed of 186,000 miles per second and is the same for all observers' viewpoint. This means that the speed of light is the same to the viewpoint of all observers.
For example, an astronaut in a spaceship who is moving towards the source of the light thinks that the light is moving at the speed of 186,000 miles per second. Therefore, if there's another astronaut who's not moving towards the source of the light, must also think that the light is also moving at the speed of 186,000 miles per second. In short, regardless of the rate of movement of the source of light and the rate of movement of the astronauts, the speed of light will remain the same. No matter how fast the observer is moving or a light-emitting object is moving, the measurement of light or the speed of light always yields the same result.
We have a short story to share to you guys and relating to our topic.
So Daisy and Kate are best friends because they are classmates since grade 11. But unfortunately, Daisy and her family needs to migrate to other country and live there for the rest of their lives due to some family problems.
Kate, on the other hand, continued living here in the Philippines happily. Even though they were milestones apart, the two girls kept in contact through social media like Facebook. Months after Daisy migrated, her birthday is coming up, and Kate wanted to greet her a happy birthday and give her a gift. Kate bought her a gift and created a happy birthday greeting card and sent it to Daisy at exactly 12 a.m. of September 20 when it is Daisy's birthday. She was so happy because she was the first to greet Daisy on her birthday. Daisy replied, "Thank you," to Kate, even though Daisy thought it was an advanced greeting since it's September 19 in their country. Daisy's reply was, "Thank you, Kate, for a very early greeting. My birthday is tomorrow. However, I am glad that you remembered it. Thank you so much."
Kate was confused with Daisy's reply.
It's already September 20, so why does Daisy said that her birthday is tomorrow?
She thought.
And because she was so confused, she went to her sister and asked. Her sister told her that there's a 24-hour difference between Daisy's place and theirs. Kate then asked why time is delayed in Daisy's place. So her sister explained to her that it has something to do relatively with the geographic location in the time zone of the country where Daisy is.
So what part of the story was the special theory of relativity demonstrated? So in the story, Kate sent the gift and the birthday greeting card to Daisy on exactly the date of her birthday, which is September 20. But according to the time of Daisy, the date was still September 19. These events happened in two different places. We cannot tell if which of these two happenings happened early than the other one, or maybe both of these happened at the same time.
This effect only becomes noticeable at speed close to the speed of light and have been proven through experiments, making the theory essential in modern physics. Thank you everyone for listening. God bless you.